Okay, so we're going to talk about expressing matrices as a product of elementary matrices, and I'm just going to do 2 by 2 matrices, but I'm going to go through like all the details in this. This is like one of those topics, I think, where it's really hard to have enough class time to do this, but it's kind of complicated, so I like having a video here because I can go through everything with you guys. So what we're going to do is we're going to express the matrix and its inverse as the product of elementary matrices. So I have this matrix here. Okay, so first of all, what are the elementary matrices? So they are really just representing row operations with a matrix. So for instance, the row operation of switching a row. So if I'm using the identity matrix, the 2 by 2 identity matrix, I just switch both rows in the identity matrix. Or another row operation would be to multiply a row by a scalar. So I can just multiply the row of the matrix by the scalar. Or the third one would be multiply a row by a scalar and add it to another row. So in this case, I multiplied this row by 3 and then added here. So that's what this would look like. So, okay. And you can choose any number. It doesn't have to be 3, obviously. Okay, so what we're going to do now is we're going to go back to this idea of expressing the matrix and its inverse as the product of elementary matrices. So the goal is that eventually I would be able to represent A, we'll call this matrix A, as so all of these E's represent as many elementary matrices as I need. I don't know how many I need, so I'm just going to write this as E sub k times ... E sub 2, E sub 1 times I. So this is just represents as many elementary matrices as I need. Okay, so in my opinion, I think that actually the easiest way to do this is to first use the inverse algorithm to figure out what the inverse is. So I know that there's more than one way to find the inverse of this matrix, but the inverse algorithm is going to honestly be money when it comes time to figure out our elementary matrices. So this is really going to do all the work that we need. So let's just use the inverse algorithm. So in this case, so I need to get this side to be 1, 0, 0, 1. So I'm just going to basically use like the same thing that you would do to get reduced row echelon form. I'm going to use that exact same process here. So I've got my 1. So first things first, I'm going to take -2 times row 1 and add it here so that I get my 0 here. So if I do that, so you can see here, so I've gone through and I did all of my math. And so I would just recommend that for you watching this video, so I'm assuming you know how to do this part. So I would recommend just finishing this and just note really clearly all your row operations. So do that and then hit play when you're ready. You're going to get more out of this if you actually do it on your own and then kind of do it alongside me. So I strongly recommend you pause here, hit play when you're ready. Okay, so to finish this, so I need to multiply this row by -1. So, okay, I'm making some more room. So I'm going to multiply this row by -1. So now here's my new matrix. And then now I've got my 1 here. So now I need this to be a 0. So I'm going to take -3 times row 2 and add it to row 1. And so in the end, so here's the matrix that I'm going to get. So you can just pause here and double check your work against mine and make sure that everything looks good. And then we can note here. So the inverse is -5, 3, 2, -1. Okay, cool. So now I think it's actually easier to find the inverse first using elementary matrices, because remember, we need to express both the matrix and its inverse as the product of elementary matrices. So it doesn't matter which order we go in. I think this one is easier. So let's do this. Okay, so the thing that we need to notice in order to answer this question is we actually need to go back and just notice all of these little row operations. And so these row operations, so remember, I can represent them as elementary matrices. So I basically just go back through my inverse algorithm and just note what I did. So now to rewrite each action as an elementary matrix, what I'm going to do is I'm actually just going to note that next to each one of these. So this was the first thing that I did. And so for that one, that is going to be so -2 times row 1 plus row 2. So here's what that elementary matrix looks like. And then for the next one, so I take -1 times row 2. Here's what that elementary matrix looks like. So I just take each step now and I represent it as its own elementary matrix. We can continue this on to the next page. So this was the last one I haven't done. So -3 times row 2 plus row 1. So bada bing, bada boom. Okay, so now I have all of my elementary matrices. And so I really just need to now multiply them all together. And I think the last question here then is, what order do you actually like go in? So do I go this order or do I go this order? So this is kind of one of those moments where if you have a calculator, I mean, you can really easily multiply these together, but like sometimes having technology next to you so you can play around really quickly can help. So I would like mess around with the order a little bit just to convince your brain of this, because sometimes I think this messes with people. But I will say this. So remember, this is our goal, to express this as these. So the one thing I will say is that in how this statement has been expressed, so it's actually pretty intuitive. This E1 is supposed to be the first action that you did to get to your inverse matrix, which means, so the first action that we did would have been, this was the very first elementary matrix that we used, right? So that's the one then that we would want to use. So in between my two options then, so what I need to make sure is I need to make sure this matrix is in the place of E1. So it needs to be at the front of the multiplication. So when I look at these two things, so it's like one of those things that can really mess with your brain, but this is supposed to be the first operation. This is supposed to be the second. This is supposed to be the third. That's the order that it's supposed to go in. And that does perfectly coincide with what you see here, right? So take a second just to convince your brain that you have the right order if that's messing with you. So I want to use this, and then really to finish expressing this as a product of elementary matrices, I just use those three matrices times, boom, the identity matrix, and now we're good to go. Okay, so I think by using the inverse algorithm, you actually make this a lot easier for yourself. Up next, now I want to do the same thing, so I want to represent my original matrix A as a product of elementary matrices. Okay, so to do this, we really want to do the opposite actions with our elementary matrices. And you can really prove this to yourself pretty easily if this is messing with your head. So you have to think about what it means to really unravel these. So if I think about, so this is really where we're at right now, right? I could name all the matrices that I have as my E sub k, or really I have three. So I'd have E sub 3, E sub 2, E sub 1, and I. So if I come back here, I, E1, E2, E3. That's how I could think of this, right? So I'm just writing this in terms of generalities just so you can kind of see why this works. So you should be able to use inverses to prove to yourself what order and which matrices you need to multiply by to get to A. So to put this to you another way, I'll just tell you the first step here. So I could multiply both sides by A. And so if I multiply both sides by A, right, so I can see then that, so A times A inverse is just going to give me I. That's one of the properties. So now I have A times all this other stuff. So think about for a second, how could you solve for A? And by the way, you'll notice that from this step to this step, I did drop I. So I is not going to impact anything in this multiplication. So I can just kind of drop it for right now so that I can analyze this particular problem, because I times any square matrix is just going to give you that same square matrix. So I can safely just drop it for a minute so that I can do some analysis on this. So here's my challenge to you. I would pause the video for a moment and see if you can solve for A just by thinking about what you know and using inverses and all that good stuff here. So remember, math is not a spectator sport. You're going to get way more out of this if you try versus just watching me do it perfectly. So I'd strongly recommend pause and do your best to solve for A and then hit play when you're ready. So I need to multiply really each one of these elementary matrices by each of its inverses. So if I think about that, so I need to multiply. So I'm just going to focus on this side for a second. Let's ignore the left side for a moment. So just focusing on this side. So I'm going to take each matrix and multiply it by its inverse. So I'm going to go in the exact opposite order. So I've got E sub 1 inverse, E sub 2 inverse, E sub k inverse. So I'm multiplying each of those. So think about how the multiplication is going to work. So in multiplying this, I'm going to have this E1 times E1 inverse. So those two are going to cancel each other out and just be the identity matrix. So we can almost think of this like canceling out. And then as I continue this, so that I'm going to have E2 and its inverse, if I multiply those two things together, those are also going to drop out. And so this pattern is really just going to continue all the way down, right, until I've canceled out all of these elementary matrices. And so then I'm just going to be left with A, right? So by multiplying each one of these inverses, I am just left with A. So now I am left with A, but we need to think about how does this action impact the equation on the whole? So remember, I was just focusing on this side for a moment. So hopefully, like, you wrote this and you're keeping everything balanced. So now I need to think about what does it mean to multiply all of these by I on the same side. So what this is going to look like is, so remember, this side, we said everything's going to drop out and I'm just left with A. So now I have I times all of these inverse matrices. Now, the other thing that I can do, because it is I can multiply I on either side. So just what I'm going to do so that I can make this what I wanted it to be is I am going to just move I, boom, here, because it doesn't matter if I is here or I is here. I is like one of the only matrices that commutes with any square matrix, right? So I can do that. Okay, so this actually now holds the key for how we finish this problem. Now I need to clearly reverse the order, right? So here was the order before. I need to reverse the order and multiply by all the inverses. Okay, so we've got our game plan. So we have to think about, how do I get the inverse? So this is what I multiplied to get my A inverse. And now I need to realize that, so for instance, the inverse of 1, negative 3, 0, 1, so this first matrix here, that inverse is right here. So you should know what the form of all of the inverses of elementary matrices are. That's a thing that you should just know off the top of your head. And you can easily prove to yourself that this is indeed the inverse, right? Because if you're not sure, you just multiply them together. If I multiply these two things together, my math is shown. So you should prove this to yourself if you're feeling skeptical. Anytime you feel skeptical about something, you should always take a moment to pause. You'll become such a stronger student if you do that every time you're skeptical. And then, okay, so now I multiply it together. I get my identity matrix. So bada bing, bada boom, we're good to go. Okay, cool. So I really have now my game plan of how I'm going to multiply these together. So this is what I multiplied together to get my inverse. So what I need to do is I just now need to reverse the order of these and also find the inverse. So this now was first, it's going to be last, and I'm going to put a 2 here instead of a negative 2. The inverse of this matrix is just going to be itself. So this will, that's going to be the exact same thing. And then this matrix, we already talked about why this is the inverse. So now notice I've reversed the order, and then I multiplied all of that by I. So there we go. So now I have my product that I need to get to A. Okay, so I don't think that that's simple. And I think it's a little bit of a technical argument. So I strongly recommend that you try a couple more of those if you're struggling with them. But it's a really good exercise for yourself to understand elementary matrices. So I'm going to leave it at that, and I will talk to you guys in another video. Peace.